Okay, today we are still doing the basic 8 trig identities. It's just a continuation of what we did on Friday, but with an added step for today. And looking at problems 1 and 2, what do you think the added step would be?
Fractions.
And when you're adding and subtracting fractions, what do we have to have? Common denominator. So that's the new part for today. So looking at problem number 1, we have 1/3 plus 1/4. Now, in order to add those fractions, we do have to have a common denominator. And what is the common denominator between 3 and 4? 12. And how did you get that 12? Where did 12 come from? Multiplying 3 and 4. That works every single time. So, the 3 had to be multiplied by 4. So, we also have to multiply the numerator by 4. And that gives us 4 out of 12. 4 has to be multiplied by 3 to get us 12, and 1 times 3 is 3. And adding fractions, add the numerator, so 4 plus 3 is 7. The denominator stays the same. So answer to number 1 is 7/12. Next one, number 2. Now, this became an Algebra 1 question. Now, if you have polynomial expressions, the same concept applies when you're trying to get a common denominator. Just multiply the denominators together. So we would need to multiply 2x plus 1 by x minus 3, and that would give us a common denominator. But we are going to leave it in factor form, and hopefully we'll have some factors canceled. Okay, so looking at that first fraction, it has the 2x plus 1. What is it missing? X minus 3. So that 3 in the numerator has to be multiplied by x minus 3. And for the second fraction, it has the x minus 3, but what is it missing? 2x plus 1. So 5 needs to be multiplied by 2x plus 1. Now, simplifying those numerators, go ahead and distribute the 3 and distribute the 5. And when we distribute the 3, 3 times x is 3x. 3 times -3 is -9. Again, leave that denominator in factor form. And distributing the 5, 5 times 2x is 10x. 5 times 1 is 5. Leave that denominator in factor form. And now that we've simplified a little bit, now we can go ahead and combine those fractions together. So adding the numerators. What is 3x plus 10x?
13x.
13x. And -9 plus 5?
-4.
Yeah, 13x minus 4 is what we'll have in the numerator. Now, when you are canceling expressions, you can only cancel a binomial with a binomial, trinomial with a trinomial, monomial with a monomial. So if I have a 13x minus 4 in the numerator, in order for it to cancel, I also have to have a 13x minus 4 in the denominator. So does it cancel? No. So that's in simplest form. And technically, we should go ahead and double distribute the denominator, but we'll leave it like that because we've gotten the concept down. Okay. Now, applying that to trigonometric expressions. So it says to simplify each expression to a what? Single term. So how many terms should I have in my answer? Only 1. So if you have a binomial, keep going. Okay, so number 3, we have tangent of x minus secant squared of x over tangent of x. Now, in order to add those fractions together, I would need to have a common denominator. And how can I change tangent of x to a fraction? I could change it to sine of x, cosine of x, or I could make this tangent of x over 1. So what would the common denominator be? Yeah, if I multiply these two together, it's just going to be tangent of x. So the second one is fine. I don't have to change anything. But if I multiplied 1 by tangent of x, I also need to multiply tangent of x by tangent of x. So whatever you do to the denominator, also do to the numerator. So tangent of x times tangent of x would be tangent squared of x. And now that I have the common denominator, I can combine those into a single fraction. So that would be tangent squared of x minus secant squared of x. Now, can I cancel tangent of x with the tangent squared? Could I cancel out one factor of tangent squared?
No.
No, this is a binomial. Is this a binomial down here? No, so that won't work. So notice both of these are square trig. So it's possible that this numerator, tangent squared of x minus secant squared of x, could be a Pythagorean identity. Let's see if it is. Sine squared plus cosine squared equals 1. If I need to have a tangent squared, what would I have to divide by? Cosine squared. Sine squared divided by cosine squared, which is tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant squared. Now, my goal, I'm trying to get tangent squared minus secant squared. So I need to subtract secant squared to both sides. And what else? Minus 1 to both sides. So that gives me tangent squared minus secant squared. What does that equal? -1. So back over here, instead of tangent squared of x minus secant squared of x, what could I put there? -1 over tangent of x. And what is that equal to? 1 over tangent of x is equal to cotangent. But because of this negative, this would be negative cotangent of x. Now I got it down to a single term, so I know I'm finished with number 3. Next one, number 4. Number 4, I would probably go ahead and multiply sine of x times cosecant of x. So instead of cosecant of x, what can I change that to?
1 over sine x.
1 over sine of x. If I make this sine of x over 1, what happens?
It just goes to 1.
Yeah, it becomes 1. So sine of x in the numerator cancels with sine of x in the denominator. Now, in order to add those, I need to have a common denominator. So if this is actually a 1 over 1, what would the common denominator have to be? Multiplying these two denominators, what do I get? 1 plus cosecant x. And both denominators have to be 1 plus cosecant x. What would I have to put in the numerator so that that is still equal to 1?
1 plus cosecant of x.
Yeah, 1 plus cosecant of x. So now that I have the common denominator, now I can combine those two fractions together. And that gives us cotangent squared of x plus 1 plus cosecant of x. What could I do next? This cosecant is part of a binomial. Is this one part of a binomial? No, so those won't cancel, so what else? What do you notice right here? Could that be a Pythagorean identity? If you have a squared trig plus 1? Let's see. Sine squared plus cosine squared equals 1. If I want cotangent squared, what would I have to divide by? Okay, so if we're trying to get cotangent squared, what would we have to divide by? Sine squared. So sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 over sine squared is what? Cosecant squared. So right over here where I circled the cotangent squared plus 1, what do I put there? Cosecant squared. So cosecant squared of x plus cosecant of x. And in the denominator we have 1 plus cosecant of x. What can we do next? Look at the numerator closely. What could we do?
Change the...
Let me ask you this. Can I cancel these cosecants because they're both binomials? No, because this is the same binomial. So somehow I need to be able to cancel it down to a single term, so somehow I have to get rid of this denominator. So how did I get a 1 plus cosecant up there in the numerator?
Do the trig identity.
No, this isn't a trig identity because only one of them is squared. Both of them would have to be squared or have a 1 with it.
The bottom one.
The bottom one too, because this one's not squared. That's not hard. Look at the numerator. Do you see anything in common?
Oh, it's the same, so yeah.
They both have a cosecant. You could factor
Oh.
GCF. What's the GCF for the numerator? Cosecant. So factor out the GCF. So factor out cosecant of x. What would go in the parentheses? Cosecant of x plus 1. And in the denominator we have 1 plus cosecant of x. Now what happens? So what happens? Yes, I have cosecant of x plus 1, which is the same as 1 plus cosecant of x due to the commutative property of addition. And my answer is what? Cosecant of x. So you can cancel a binomial with a binomial as long as they are the same binomial. So cosecant of x is the answer. Next one, number 5. We have tangent of x plus cotangent of x over secant squared of x. What could we do with number 5?
So we put tangent and cotangent in fraction form?
Okay, so we could change everything to sines and cosines. So this would be sine of x over cosine of x plus cosine of x over sine of x. And I'll leave the denominator as secant squared for right now. Now, can I add those two fractions to the numerator? What do I have to have? Common denominator. What would the common denominator be? Yeah, we have to have cosine x and sine x. So this would be sine x, cosine x, and sine x, cosine x. So this first one had cosine, so what was it missing? sine, so multiply the numerator by sine, and sine times sine would be sine squared of x. And the second one had sine, what was it missing? Cosine. And what's cosine times cosine? Cosine squared of x. And in the denominator we have secant squared of x. Now I can go ahead and combine those two fractions in the numerator, and that would be sine squared of x plus cosine squared of x over sine of x, cosine of x. And in the denominator, it's still secant squared of x. What can I do next?
In numerator, when you take sine out of sine, cosine, cosine, so it'd be sine plus cosine.
Future factor?
This one doesn't have a sine x and cosine x to be able to factor that out. So here, we don't have a common factor here. And this is a binomial with a monomial. But look, right here.
That's one.
Yeah, sine squared plus cosine squared is what? One. That's our Pythagorean identity, right? So this is 1 over sine of x, cosine of x. And let me do what others were suggesting, and what should I do with that secant squared? Change it to 1 over cosine squared. And now I'm ready to divide those fractions. And when you divide fractions, you multiply by the reciprocal. So when I multiply by the reciprocal, that would be cosine squared of x over 1. Now cosine of x in the denominator will cancel only one factor in the numerator. So I'm going to slash out the 2, and it drops down to just cosine to the first power. So that leaves me with what for the top? Cosine of x, and what about in the denominator? Sine of x, and cosine of x over sine of x is equal to cotangent of x. It took us a while, but did we get it down to a single term? Yes, we got it down to a single term. Okay, next section. Now it's changed on us. It says simplify the left side to equal the right side. Now, if you're trying to check your answers with the Photo Math app, it will lead you astray because it will do operations to both sides of the equal sign. But is that what the instructions say here? No, it says to simplify the left side. So the only side you should be doing operations with would be the left side. So just recopy the left side. We have tangent of x plus cotangent of x. Any ideas of where we could start there? Change everything to terms of sine and cosine. Instead of tangent, I could change that to sine over cosine. Instead of cotangent, I could change that to cosine over sine. What could I do next? Yeah, what's the common denominator? Sine cosine. So the first one has cosine, what is it missing? Sine. If I multiply the numerator by sine, sine times sine would give me sine squared of x. This one has sine, what is it missing?
Cosine.
Cosine. So what's cosine times cosine?
Cosine squared.
Cosine squared of x. equal?
One.
1 sine squared plus cosine squared is 1. And I have sine of x, cosine of x. Oh, and we're finished. We just showed that the left side equals the right side. So start with the left side, prove that it does equal the right side. Next one. Again, we're starting with the left side. So here we have a binomial squared. So we have secant of theta plus tangent of theta for the binomial, and we need to square that. And remember the shortcut for squaring a binomial. Here it is. A plus b if you square it. You square the first term. You multiply these and double it to get you 2ab. And you square the last term to get you b squared. So the same process over here. When you square the first term, what do you get? Secant squared of theta. Multiply these and double it, what does that give us?
2 secant tangent.
Yeah, 2 secant theta, tangent theta. And when we square the last term, what do we get? Tangent squared of theta. Any ideas? What can we do next? Change everything to terms of sine and cosine. So instead of secant squared, I could change that to what? 1 over cosine squared. I'll make this 2 over 1. Instead of secant, I could change that to 1 over cosine. And instead of tangent, I could change that to sine over cosine. And instead of tangent squared, I could change that to sine squared over cosine squared. And multiply these 3. That should be an equal sign, that should be a plus sign. So 2 times 1 times sine of theta would give us 2 sine of theta in the numerator. And in the denominator, 1 times cosine would give us cosine squared of theta. And now that we have the common denominator of cosine squared, we can go ahead and combine all 3 of those fractions together. So add all 3 together. And I'm going to put it in standard form. So I'm going to write the sine squared of theta first, and then the 2 sine of theta, and then the 1. So writing it in standard form, highest power first. Now on Friday we talked about these can factor tricks. And up here in the numerator, that is called a perfect square trinomial. Put your parentheses with the square. Square root of the first term, what's the square root of sine squared of theta? Sine of theta. And square root of the last term, square root of 1 is 1. The middle term is positive, plus sign in the middle. Now, let me go back to the top. We're trying to get this to equal 1 plus sine of theta over 1 minus sine of theta. Well, first of all, do we even have sine in the denominator? No, so I need to replace cosine squared with something else. So use the Pythagorean identity. Sine squared plus cosine squared equals 1. If I want cosine squared by itself, what would I have to do? Subtract sine squared. So cosine squared equals 1 minus sine squared. So instead of cosine squared, what can I put? 1 minus sine squared of theta. But do we want 1 minus sine squared of theta in the denominator? What do we want? 1 minus sine of theta. And do we want sine of theta plus 1 squared in the numerator? We only want one of those factors. So that means we have to have something cancel in both the numerator and in the denominator. So we need to factor further. So down here in the denominator, 1 minus sine squared, what is that called when you're factoring? A difference of squared? Yeah? Remember if you have something like x squared minus 9, you would have x plus 3, x minus 3, right? Same principle here. Instead of 1 minus sine squared, what would our two factors be? Square root of 1, what's the square root of 1? So both of them will have a 1. One will be a plus, the other will be a minus. And what's the square root of sine squared? Sine. So 1 plus sine of theta, 1 minus sine of theta. Now do we have something that would cancel? Yes. Sine of theta plus 1, 1 plus sine of theta, those binomials are the same. So 1 in the denominator will cancel with only 1 in the numerator. So slash out the 2, it's going to drop it down to only one of them. So that leaves me with sine of theta plus 1 over 1 minus sine of theta. Is that what we have on the right side? Does it match exactly? No. What are we supposed to have in the numerator? 1 plus sine of theta. So commutative property of addition. I can rearrange that order to 1 plus sine of theta over 1 minus sine of theta. So now we finally got the left side to equal the right side. Okay, the last one. I want you to do this one. So for number 8, start with the left side. You need to start with 1 over 1 minus secant of x plus 1 over 1 plus secant of x. Do some operations with that so that you get it to equal the right side. have 1 minus secant, 1 plus secant. Okay, so the first one has 1 minus secant, so what is it missing? 1 plus secant of x. The second one has 1 plus secant, what is it missing? 1 minus secant of x. Since we have the common denominator, adding those fractions together, 1 plus 1 is 2, secant of x, negative secant of x, those add to 0. And in the denominator, 1 minus secant of x, 1 plus secant of x. Now, do any terms cancel, or any factors cancel? No, so I need to go ahead and multiply those denominators. There's the only one denominator, it's not multiple, it's just one denominator. So multiplying these two binomials, what do you get? One minus secant squared of x. And what should you be thinking when you see a 1 with a squared trig function? Yeah, it is a difference of squares, and we already had it in factor form here. But if you have a 1 with a squared trig, it's probably going to be a Pythagorean identity. So let's check it. Sine squared plus cosine squared equals 1. If I want to have a secant squared, what do I have to divide by? Cosine squared. So divide all three of these by cosine squared. Sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared is 1. 1 over cosine squared would be secant squared. So if I have 1 minus secant squared, what does that equal? Yeah, negative tangent squared of x. I would have to subtract 1 to both sides, subtract tangent squared to both sides. Oh, sorry, I don't have to do anything. I did it backwards. What should I have subtracted? Secant squared. I want 1 minus secant squared. So 1 minus secant squared. And subtract tangent squared. So that gives me 1 minus secant squared is equal to negative tangent squared. Okay, so if I have 1 over tangent squared, what is 1 over tangent squared equal to?
Cotangent.
Cotangent squared, but I don't have 1, I have this 2 and the negative. So this would be negative 2 cotangent squared of x. And is that what we needed to stop at for the right side? Yes. Negative 2 cotangent squared of x.